Here we are looking at the problem set for 5.2 through 5.3. I just wanted to go through number one to look at what exactly I expect of you in doing these multiple choice questions, these first few, where I say to justify each answer choice. Okay, so it's not enough work for you just to circle the right answer or just to discuss the one right answer. I want us to actually use this as a learning opportunity and go through each answer choice and explain, why or why not it is the right answer. Okay, so the way I'm going to be doing number one is how I want you to do, let's see, 2 and 3. Anytime I say justify each answer choice, this is going to be what I'm looking for. All right, so in number one, it says, which of the following functions of x is guaranteed by the extreme value theorem to have an absolute maximum on the interval, closed interval from 0 to 4? So if you recall the extreme value theorem, the conditions of the extreme value theorem is that the function needs to be continuous on the given closed interval. If that is the case, if you are continuous on the closed interval, then you're guaranteed to have both an absolute maximum and an absolute minimum. That's all you need. It just needs to be continuous. So in each of these answer choices, all we have to do is address the continuity of that function and on the interval from 0 to 4. Okay, so if I'm looking to justify each answer choice, we're just discussing the continuity of each of these. So tangent of x is our first one. So hopefully you remember tangent of x looks like this. We've got asymptotes on either side of this almost cubic looking graph, right? So the asymptotes, if you recall, for tangent are at negative pi over 2 and pi over 2. So we're going to be discontinuous at every kind of odd multiple of pi over 2. So all you have to do is show that you have are continuous from 0 to 4, or to show it's not an answer, discontinuous somewhere. So if I'm discontinuous at pi over 2, you think, is that inside the interval from 0 to 4? Yeah, 0 to pi over 2, hopefully everybody understands, is about 1.57, right? Half of 3.14. So of course that's going to be in the interval. So all you have to do to justify it, you don't even have to draw the graph. I was just showing the graph for you to remember, is just to state that this is discontinuous at pi over 2. Okay, it's discontinuous at other things, but pi over 2 is an easy one to see that is in the interval, and therefore the extreme value is not going to apply. All right, so now let's talk about inverse tangent. So here I've graphed for you the graph of tangent. And so if I were to consider the graph of inverse tangent, that flips that graph of tangent across the line y equals x. So what happens is you get this function right here, and those vertical asymptotes now become horizontal asymptotes at pi over 2 and negative pi over 2. All right, so if you consider the graph of inverse tangent, if you think about where this is discontinuous or continuous, notice it's never discontinuous, right? It goes on forever and ever to the right. Now, the horizontal asymptotes don't mean it's discontinuous. It's just going to keep going and kind of follow along those lines. So this is continuous everywhere. All right, inverse tangent is continuous everywhere. So therefore, it is continuous for sure on the interval from 0 to 4. So this is going to be our answer. Now, you can't stop there though, because I did say justify each answer choice. So all we've got to go through is just talk about the continuity of the other two problems. So in part C, we have a rational function. So to talk about when a rational function is discontinuous is when the denominator is discontinuous. So this is just really good practice in considering basically like when a function is continuous or not. So you need to be readdressing those skills. So this is discontinuous when the denominator is equal to 0, or if I factor that, right, that would be x plus 5 times x minus 4. So this is discontinuous at x equals negative 5 and 4. So then you check your interval. 4 is inside that interval. So it's not just inside the interval, it's an endpoint. And to be continuous, you have to be everywhere in between 0 and 4 and also at the endpoint. So this is an endpoint of my interval. So therefore, this is discontinuous on that interval, closed interval, and not the answer. So finally, in part D, it's not rational because of e to the x, but we have the same idea. We have this quotient. So this is going to be discontinuous when that denominator is equal to 0. So when e to the x minus 1 equals 0, or in other words, when e to the x equals 1. So to solve this, just think at what power, right, is e to the what power is equal to 1? Well, that's when x is equal to 0. And again, this is that other endpoint on our interval from 0 to 4, so therefore not the answer. So this is just a very brief way of just justifying each answer choice, just talking about where they're continuous or discontinuous. All right, so that's what I'm looking for those types of questions.